everyone. So for this, I'm calling it Practice Worksheet 2.1 just to kind of follow the same pattern. But what I'm actually going to do on this one is go over the workbook that you just did. So this is workbook 2.1. The questions at the end of this, or the questions on this workbook, I think are really tricky and difficult. So we're going to go over them. We just went through the notes here, and what they did is they told you, like the rule of how to change radicals to exponents using the fractions. But then in the problems down here, they jumped into stuff that's like, I feel like way harder. Anyway, so I'm going to go over them with you. And then you can go back and change your workbook answers if you got any of them wrong. Yeah, just so you know, you can always redo workbooks as many times as you want. Okay, so how can the square root of 25 squared be rewritten? So you have to select all that apply. So select all that apply are always a little bit tricky because you got to make sure you get all the right answers. So looking at 25 to the second power, so that means they just took away this square root without doing anything else. So that's not allowed. You can't just take that away. So no to that one. The square root of 5. So they turned the 25 into a 5 and took away the squared. That doesn't make sense, so that one's out. The square root of 5 squared. So they just changed the 25 to a 5. That can't be right. 5 squared. So that, what they did is they took the square root of 25, just that part right there, and they actually did the square root of 25, which is 5. So that's right. So this one should be selected. And then 25. So 25, what they did is the square root and the squaring. Remember, those are inverse operations, is what we talked about in this lesson. So those do cancel each other out, and the answer can just be 25. So these bottom two are correct, and you can see that 5 squared equals 25, so that makes sense that those ones work. Okay, this next one is matching. So match each radical expression with the equivalent exponential expression. Okay, so 3, the fourth root of 3. So the fourth root is going to become the fractional exponent 1/4. So we need 3 to the 1/4. And so that's this one. So you would drag it up there. I can't do it because I'm not on that screen. The square root of 3, that would be the square root is going to become the fractional exponent 1/2. So we should be looking for 3 to the 1/2. So there it is. The fifth root of 2, so that's going to be 2 to the 1/5 power. There it is. And the cube root of 2, so that'd be 2 to the 1/3 power. So we drag that over there. So that one I feel like wasn't that bad. Hopefully you felt good about that one. Okay, this one, oops. So evaluate 49/64 to the 1/2 power. So if you remember our rules about exponents, you can distribute that 1/2 power to both the 49 and the 64. And here I'm going to actually flip over to my paper. Oh, it always does that. I got to reopen it. So 49 over 64 to the 1/2 power. So remember, we can distribute that 1/2 power to the top and bottom of the fraction. So I get 49 to the 1/2 power over 64 to the 1/2 power. And I know that the 1/2 power is the same as the square root. That's what we just learned in this lesson. So this is like the square root of 49 over the square root of 64. And then the square root of 49, what times itself is 49? That's 7. And square root of 64 is 8. So my answer would be 7/8. So that's how you do that one. Okay, and then, so this will be similar, the cube root of 27 over 125. So let me write that down real quick. The cube root of 27 over 125. Okay, so just like you can do with the exponents, distributing it to both pieces inside the fraction, I'm going to do the same thing. So this is the cube root of 27 over the cube root of 125. So cube root means what times itself 3 times equals that number. So something times itself 3 times equals 27. So that thing is 3. You can also use a calculator to figure that out. And then for 125, that is 5. 5 times 5 times 5. So 3/5. Evaluate 32 to the 1/5 power. So 32 to the 1/5 power, That's the same as the fifth root of 32. So something times itself 5 times has to equal 32. Well, it's got to be something really small, and what it happens to be is 2. If you do 2 times 2 times 2 times 2 times 2, you get 32. And remember, you can use your calculator, you can use the online calculators, whatever works best for you. And last, suppose 12 is raised to the second power like this, 12 to the second. Which answers show the inverse operation? So the inverse of squaring is square rooting, or raising it to the 1/2 power. Those are the same thing. So here I see the square root of 12, so that's the inverse. And then 12 to the 1/2 power is also the inverse. And these other ones are not correct. So hopefully that helps a little bit on that workbook. So you don't need to submit anything for this video. You just watch it and then go back and correct your workbook if you need to. Other than that, I'll see you on the next video.